You were introduced to the quadratic formula in Algebra 1. However, you never used it using complex numbers. Now that we've introduced you to complex numbers, we can use it to a greater extent. So we'll begin with the standard form of a quadratic being ax squared plus bx plus c equals equal to 0. Keeping in mind that a, b, and c are coefficients, or the numbers in front of the variables. We present to you the quadratic formula in all its glory as being this monstrosity. We're going to show you how to use it in the second video. There are some key features to this that were not brought up before in the past. One is in the future, when we're graphing, this will be an integral part of identifying geometry for a parabola. We're not going to do that right now. The second key feature is that inside of this radical is an expression that we call the discriminant. So that's going to be b squared minus 4ac. We will not prove this formula at this point, but we will soon hereafter. It's a very appropriate and rigorous proof that is meant for Algebra 2. And in case if it was never brought up, notice that the formula has a plus or a minus. And this indicates that there's two solutions. We've established through all these videos that quadratics, being of the power of 2, can have up to 2 solutions or roots. So the inside of the radical is known as a discriminant, and that's b squared minus 4ac. If we go ahead and use that by using the coefficients of a quadratic and calculate it, we're going to get the discriminant, and it's going to help us describe the roots or the answers. So it's not going to give us the answers, but it's going to say, hey, the answers are going to be like this, or they're going to be looking like this. So there's 3 possible outcomes if we do the discriminant. In the first case, if it's negative, we'll get a negative answer. So if it's less than 0, if it's equal to 0 or exactly equal to 0, and then if the discriminant is greater than 0, in other words, if it's a positive answer. So if the discriminant is negative, this is where we head into Algebra 2 territory. It's going to tell us that the answers are complex or imaginary roots. In other words, if we do the discriminant, it's going to tell us, hey, your answers are going to have an I in it. Remember that the square root of -1 is an I. That's the imaginary unit, and we use it for complex numbers. So if you do the discriminant, I's are not going to pop out, but it's going to tell you, hey, when you do the actual work, it's going to have an I in it. Okay, so the discriminant is used to describe or to predict what's going on. If we do the discriminant and it's equal to 0, then it means that I have a double repeated root. So I should probably get rid of this roots, because this is a double repeated root. And if you forgot what that looks like, it means if I get to a point where I solve a problem and I get x equals 2 and x equals 2, well, we got 2 answers, but the thing is that we got twins. So we technically got only one answer. It happens to be repeated or a double root. And then if d is greater than 0, if it's a positive answer that we get for the discriminant, that means I'm going to have 2 different real roots, which is what you're traditionally used to for these kinds of problems. It can also predict in general what our graph is going to look like. So we've kind of talked in the past briefly that the graph of a quadratic is called a parabola. You'd remember the football throwing problem. So here we have 3 parabolas, graphs of a quadratic, and if the discriminant is negative and if it's complex imaginary roots, it means that it never touches the x-axis. But if it's a double repeated root, it touches it at exactly one point right here. So a double repeated root touches the x-axis once, and that's a repeat. But if I have 2 different real roots, it's going to touch it twice because I have 2 different real roots. So notice, like, if I have 2 roots, well, there they are, literally. If there's one that repeats, well, it's right there on the x-axis. And if I have this one, well, it never touches because there are no real roots. I only have complex roots. Okay, you'll see what that looks like in a bit. So let's describe, right? It's asking for us to describe. It's not saying to solve. Okay, describing means I'm going to use a discriminant. The discriminant doesn't give you the answers. It doesn't give you the roots. It just describes the roots. So if I use this, I'm going to use b squared minus 4ac. The key to this video and the next really is, do you know how to do order of operations? and can you use parentheses, which we've been doing with functions since last semester. So I've been kind of preparing you for this moment. Okay, what is b? Well, b is positive 4. So that goes in here. A is this positive 2. And C is this positive 3. Now, if I do order of operations, I'm going to do 4 squared first, which is 16. And then I can multiply these 3 together. 4 times 2 is 8 times 3 is 24. And if I do 16 minus 24, I get negative 8. Now, based on what we just wrote, if the answer is negative for the discriminant, then how does it describe the roots? Describe means you're using words. So if you look at the negative discriminant and you look at the column next to it with a description, it says complex imaginary roots. So because I get a negative 8, I can say that this quadratic has complex imaginary roots. So if I were to actually do all the math and solve, I'm going to find that it has i's, imaginary numbers in them. Try out part B. It's the same process, right? For part B, A is 2, B is a positive 1, C is a positive 4. Remember, it's the numbers, not the letters. So don't do the discriminant and use X. Use the number in front, which is a 1, not a 0, a 1. So, set it up, right? B squared minus 4AC. Use the parentheses. Plug them in. Do order of operations. I'm not going to do that for you. You should get that the discriminant is negative 31. Now, if it's negative, what does it say about the roots? Well, in this case, it says that they're complex imaginary roots. So this is true also for part B. Fascinating. Part C, we can't quite do part C yet. So we need to make sure that our quadratic equations are always equal to 0 if I'm going to use discriminant or if I want to use a quadratic formula. Now, I'm not saying always, because you've seen problems in the past where we didn't set them equal to 0, we square rooted. And in the future, if we do completing the square, we're not going to set them equal to 0. In this case, if I'm using the discriminant, this might be a good left column idea. If I'm using the discriminant or the quadratic formula, yes, you must have it equal to 0. So I need to make this equal to 0. I do that by adding 34 to both sides. And now I'm ready to use the discriminant. So A is positive 1, B is negative 10, C is positive 34. Right? There's a 1 in front. A is not x squared. A is not 0. Okay, B is not negative 10x. I know the common mistakes you guys are going to be doing. We're just writing down the numbers in front of the letters. So we set up the discriminant, b squared minus 4ac. This is the discriminant which is used to describe. I plug in these numbers, positive 1, positive 34. If you didn't use the parentheses, you're going to get some wrong answers. Okay? Because negative 10 times negative 10 is a positive 100. If you didn't put the parentheses, you might get a negative 100, and you could possibly get a different answer. Over here, I have 4 times 1 times 34. That's going to be 136. And if I subtract those, I get negative 36. And I don't know what's going on here, but we got another negative answer. And so if I describe C, I'm going to describe it again as a complex imaginary root because we got a negative discriminant. Let's see what happens with part D. A is 1, B is 9, C is 14. We do b squared minus 4ac, positive 9, positive 1, positive 14. 9 squared is 81. 4 times 1 times 14 is 56. 81 minus 56, well, that's 25. Oh, snap, we finally got a positive answer. Okay, great. So if it's positive, let's look at our column. Description of roots. So if d is greater than 0, if it's positive, then the the roots are two different real roots. Okay, so let me be very technical here with a few things. One, all of these quote unquote answers that we got, for example, for part D, we got this answer, quote unquote. This is not the answer. This is the discriminant's value. Okay, so the discriminant D is equal to positive 25. And if D is positive 25, then that means that the description of the roots is two different real roots. This D equals 25 is not the root. It's not one of the roots. Okay, we haven't solved for the quadratic at all. We've only found a description for it. So to give you a better perspective, let's say you're asked to go clean someone's house, okay? And you don't know what kind of a problem you're walking into, but you go to this person's house, and then as you walk in, you see the cleaning supplies they give you. Based on the cleaning supplies that you see, you can be like, okay, I can get this much done, or maybe I can get this much of the house cleaned, or I can do this good of a job or this bad of a job. And so the cleaning supplies are kind of like the discriminant. It kind of like allows you to predict, okay, this is how much I can do, or how much I'm going to charge you for this job, right? If you provide me a lot of these cleaning supplies and vacuums and whatever, then it's going to be an easy job. But you're only going to be able to predict how efficient and effective you'll be based on what you're given. And so the description is going to allow you to come up with the solution or to predict what the outcome will be like. So anyway, with that being said, what can a discriminant be used for?